So homework from last day, number 7. Yeah, well, here's what I see. I sort of on the top see this. See it? And because I'm a good student by now, I probably have my formula sheet out, or I might have it, maybe I've memorized all of these. I doubt it. So I would have my formula sheet in front of me, and I would say, hey, I see cos squared minus sine squared. This is cos 2 theta on the top there. Except instead of a theta, what do I have sitting where the theta is? 3 over 2x. So the top is cosine of 2 times 3 over 2x. Oh, 2 times 3 divided by 2. You know what? I think the top just works out to cosine of 3x. Is that okay so far? Okay. The bottom. Well, here I see sine theta, cos theta, which I don't quite have on my formula sheet. On my formula sheet, I have a 2. Oh, no. We said actually I do, because that's also the same as a 1/2 sine 2 theta. You're in physics, you're used to rearranging stuff, so you have a bit of an advantage. I think the bottom is 1/2 sine of 2 times 3 over 2x. I think the bottom is 1/2 sine 3x. You okay with that so far? So I think this whole thing is this. Cos 3x all over 1/2 sine 3x. That's a start. I glance at the answers. Well, I'm probably going like that in my mind, if nothing else. I don't quite see my answer. Wait a minute. Dividing by 1/2. What's that the same as multiplying by? A 1/2 in the bottom is the same as what? Now, ready? Someone over there said it quietly, but you've forgotten. Is 1/2 the same as that? Yeah? What does a negative exponent do? Oh, elevator! One half on the bottom is same as a 2 on the top. Dividing by 1/2, same as multiplying by 2. Okay, yes? Oh! What is cos over sine? What was sine over cos? Tangent. So what's cos over sine? So what's cos 3x over sine? 3x, cotangent of, with what in front? Gotta be that. And then once again, as you've heard me say many times this year, for a curveball question, I'll say, did I do anything new? No, stubborn and clever, and not going to freak out. Now, I probably would have saved this question for last if I saw it on a test, but we'll start. I would have thought about it for 30 seconds to get my brain thinking about it. Then I move on, because I know somewhere part of my brain keeps working on it subconsciously. I don't know how it works, but it does. Then I would have come back to this at the end. Okay? Any others? Okay, we're going to be finishing off identities today. Then we're going to spend 2 days looking at trig applications, word problems. And then we're done. If you're trying to plan when your test is going to be then, so I don't see you for a week, that'll be word problems part 1. I assume next week on Friday is the Monday schedule, because that's the day of the week that we lost. That would make sense. So that'll be word problems part 2. Okay. I'm thinking your test is going to be either the week after that or the beginning of the week after that, more likely. That make sense? I'll send out an email with more details when we get closer, but some of you like to know. We skipped lesson 7 to do lesson 8 because it was a short lesson. Lesson 7. Can you turn to lesson 7, please? Page 351. And also, again, get out your calculators and pick up things that you've dropped on the floor. Last day we asked a question. Last day we asked, is this true? We said, is that true? Trevor, we said, nope, it's not. Today we're going to ask a different question, but very similar. We're going to ask, is that true? If I add two angles and then find the sine, do I get the same answer as if I find the sine of the first one and the sine of the second one? In other words, Andrew, what we're really asking is, can I do this? Can I somehow distribute the sine? And it says, describe or determine whether or not the statement can be verified for 60 degrees and 30 degrees. Degrees? Yeah, I'm not going back to degrees. Let's see if it can be verified for pi by 3 radians and pi by 6 radians. So what we're asking is, does the sine of pi by 3 plus pi by 6, is that the same as the sine of pi by 3 plus the sine of pi by 6? So get your calculators out and try typing this in, see what you get as a decimal, make sure you're in radians. Then try typing this in, and do you get the same decimal? Let's see, the sine of pi by 3 plus pi by 6, so that's what the first section looks like. Oh, 1, that's kind of nice. Compare that to the sine of pi by 3, close bracket, plus the sine of pi by 6, close bracket. Do I get 1 again? So Shannon, are these the same? No. What can we say? It's false. So then the question is this, Shannon. What is the sine of one angle plus another angle work out to if it doesn't work out to the sine of the first plus the sine of the second? I'm not going to prove these ones because the proofs are fairly ugly, but as it turns out, the sine of one angle plus another angle is equal to the sine of the first cos of the second plus cos of the first sine of the second. Those work. Oh, and you know what? The sine of one angle minus one angle is equal to the sine of the first cos of the second minus cos of the first sine of the second. Those work. Those two will give you the same decimal on either side. If you're bored, you can try it, but they do work. Oh, and as it turns out, Katie, the cosine of one angle plus another angle is equal to cos of the first, cos of the second, minus sine of the first, sine of the second. Oh, and by the way, the cosine of one angle minus another angle is actually equal to cos of the first, cos of the second, plus sine of the first, sine of the second. They work. We write them generically as follows on your formula sheet right here. These are what we call the sum and difference identities. These are the addition identities. And see if you can spot where they are on your formula sheet. I think they're about, what, 1/4 of the way down? Yeah? See them all there? We use alpha for the first angle. We use beta for the second angle. These are the ones that I haven't memorized. I've kind of fibbed to you. Most of the other trig identities I have memorized. These ones, they all look so much alike, I do get them confused. Be really careful when you're copying them out, because often, Ashley, I'll see copying errors. When do I know to use these? Oh, it's pretty simple. Either I have two things being added or subtracted in the brackets, or I see sine cos cos sine, or cos cos sine sine, or sine cos. I see something like the right hand side. Mr. Dueck, yeah. Why don't you have a tangent sum and difference identity, because tangent is sine over cosine, so why would I need one? It would be the sine identity over the cosine identity. No, good point. Okay. So let's use it. I don't know if you've ever asked yourself, hey Dueck, in the pre-calculator days, we've agreed we can find 30 degrees, pi by 6, and 60 degrees, we got those from our special triangles, Leah, and 45 degrees, pi by 4. Hey Dueck, how do they find other angles? Well, for example, how would they have found an exact value for 15 degrees? Well, we're going to go back to degrees a little bit here. What are the angles that we know in degrees as exact value? As exact values. We know. Yes? What other angles do we know? 60. What else? 45. And 90. And any multiples of those. So here's my question. Can you use two of those angles to write an addition or subtraction question that works out to 15 degrees? Amanda, which two? Ah, this is really the same as the sine of 45 degrees minus 30 degrees. Is that not the sine of 15? Yeah. Except now we're going to expand this using one of my trig identities. In fact, this looks like the sine of alpha minus beta. Does it not? So I would find that, it's right here. And I'm going to write this out, except, Nicole, wherever I see an alpha, you know what I'm going to put? 45. Wherever I see a beta, you know what I'm going to put? 30. So I'm going to say that this works out to sine 45 cos 30 minus cos 45 sine 30. You know what else? Just so we have these on the page, how about right here? Let's put our two special triangles. So we have the 1, 2, root 3, and the 1, 1, root 2, where this angle here was 30 degrees, or pi by 6. This angle here is pi by 3, or 60 degrees. This angle is 45 degrees, or pi by 4. By the way, my trigger phrase to know that I'm doing special triangles, exact value. Remember that little trigger phrase from last unit? Okay. What is the sine of 45 degrees as an exact value from this special triangle? What over what? Sorry? That's the angle. I want the sine. We're not going radians. We're committed to degrees here. What's the sine of that angle right there? What over what? 1 over root 2. That's that expression right there. Apparently, the sine of 45 minus 30, which, Holly, is the sine of 15, is equal to sine times cos minus cos times sine. So what's the cosine of 30 as an exact value from this triangle? What over what? What's sitting right there, Shannon? Drop it down. Sabrina, what's a cosine of 45 as an exact value? What over what? Cosine adjacent over hypotenuse, so adjacent over hypotenuse. Yeah. By the way, 45 sine and cos happen to be the same because it's that triangle. Yep. Good. Oh, that is so thoughtful. A week from today, first thing in the morning, how thoughtful of Andrew to offer to bring us Timbits. So nice of you. Now, that's actually an alarm, not a ring. Is this like time to wake up now? Okay. Oh, Andrew, what's the sine of 30? For me? No, not a decimal form. Why would we go to decimal form? What are we doing? Why do we go to decimal form? What's the sine of 30? No, that's the angle. What's the sine of 30? Pi by 6 is radian. What's the sine of that angle? You guys are missing what we're doing here. I'm a little worried here. I'm losing you guys. Yeah? 1 over what? No. You're really flustered by that alarm, mister. Opposite over hypotenuse. What's the sine of 30? It's a half. Let me pause. You guys see what we're doing here? We're trying to find an exact value for 15, but we don't have a triangle that has a 15 degree in it. But what we can do is write an equation that works out to 15 degrees that has angles that we know in it as exact values, and then find those sines and cosines as exact values. And now we can even go one step further, because here I have 1 fraction times 1 fraction. Nathaniel, how do I multiply fractions? It's the easiest one. Top times top, bottom times. In other words, it's going to be 1 times root 3, which is root 3 over 2 times root 2, which is 2 root 2. And then Nathaniel, what's sitting right here? Yeah. When I multiply these two fractions together, Nathaniel, what am I going to get on the top and on the bottom? Yeah. Oh, do I have a common denominator already too? Heck, let's write it as 1 fraction. It's a common denominator. Why not? This is going to work out to root 3 minus 1 over 2 root 2. That is actually the exact value of the sine of 15. There it is. What other angles could I come up with out of here? Oh, by the way, we could have gone 60 minus 45 instead of 45 minus 30. We would have got the same answer in the end. You can also try adding angles together. For example, 45 plus 30, I can get the sine of 75 if I want to. Mixing and matching any of those ones, I can get more angles. Oh, and then once I have those angles, back in the old days, you would write those down, and now you can mix and match more angles to find more exact values, and you could just start churning. You could usually work your way and get about 80% of them using these identities. Yeah? So, example 2. I like example 2. I like example 2. Example 2 is a nice question. Andrew, can you read to me example 2, please? Oh, do you want me to go as a decimal? How do I know? Ah! Oh, bit of a problem. Have I memorized triangles with 12s in them? No. But are we radians or degrees here, and how can you tell? Radians. Well, you know what? Off in the margin, let's list the angles that we know in radians in our special triangles. What are the angles that we know? Steph? Pi by 3 is one of them, I agree. What else? Pi by 4, pi by 6. Those are the 3 main ones. Oh, and pi by 2, which is 90. We may use that, we'll see. Except, Steph, what's my denominator here? Why don't I be clever and write these all as something over 12? So a 3 I would times by 4. This is 4 over 12. A 4 I would times by 3. This is 3 over 12. And the 6 I would times by... So here's my question. Using adding or subtracting, can I get a 5 pi out of over 12 out of any 2 of those angles by adding or subtracting them? Shannon nods. Which ones? And? Because pi by 6 is 2 pi by 12, which doesn't get me there. Combine it with what else? Yeah, you know what? If I add these two together, I'll get 3 pi by 12 and 2 pi by 12, which I'm pretty sure is 5 pi by 12. Okay, so here's my plan of attack. This is really this. Yes? Secant goes with which trig function? So here's what I'm going to say. This is really going to be the cosine. Put your pencils down, please, for a second. Of 3 pi by 12. Wait a minute, Mr. Dueck. Pi by 4 plus 2 pi by 12 pi by 6. Except once I'm done, this is going to give me the cosine. How would I find the secant if I know the cosine? The very, very end, what am I going to have to do with my final answer? How are secant and cosine related? Amanda? So once I know cosine, how will I find the secant? Flip it, okay? Pick your pencils up. So we're going to do this. And I'm going to argue that this looks like cosine of alpha plus beta. Something plus something. Yes? Okay. Roxanne, can you do me a favor? At the top of the page or from your formula sheet, can you find the cosine of alpha plus beta identity? See it there somewhere? Found it? Yeah? Yes? I can't read your body. You don't sound confident. There's 4 identities in a big box there, yes? Find the one that says cosine of alpha plus beta. I think it's the third one, yeah? Okay, you got it? I'd like you to read me the right-hand side, except instead of alpha, look up. Can you say pi by 4? And instead of beta, can you say pi by 6? What am I going to write? Okay. Is that okay, Steph? Birthday's not pure for a bit. Stay focused. All right. Ready, Andrew? Scene 1, Act 1, Take 2. From the 2 triangles, did you draw the 2 triangles up there? Okay. Hey, what is the cosine of pi by 4? Go find the one that has pi by 4 in it, and then tell me the cosine of that corner. Oh, okay. 1 over root 2 times, Itzel, what's the cosine of pi by 6? Root 3 over 2. And then minus, according to this identity. Carson, what's the sine of pi by 4? It also 1 over root 2. Tyson, what's the sine of pi by 6? Did you draw the triangles like I said at the top of the page? Did you draw the triangles that I said at the top of the page? You did? Okay, that's first thing. So you got your triangle there. There's pi by 6, yes? Sine is what over what? Sine is what over what in terms of opposite, adjacent, or hypotenuse? Opposite, yes? Over hypotenuse? What over what? Hey! Good recovery. No one noticed. Sorry. Oh, and then Tyson, how do I multiply fractions? Top times bottom times? So this will simplify into root 3 over 2 root 2 minus 1 over 2 root 2. Yeah? Oh, do I have a common denominator already? Oh, even more gooder, because this will simplify to root 3 minus 1 over 2 root 2. Yes? Except Amanda, That's cosine. They didn't ask us for the cosine. Amanda, what did they ask us for? The secant. Oh, if I know the cosine of 5 pi by 12, which is apparently that. How do I find the secant? I guess the secant of 5 pi by 12 is going to be 2 root 2 all over root 3 minus 1. Now, I am good with you leaving both of these answers in this form. Do you notice there's a square root in the denominator, Steph? And there's a square root in the denominator? The answers in the back of your book are going to do with that rationalizing the denominator thing. I'm not going to make you do that. So when you get your answer and you look in the back and theirs looks different, type this into your calculator as a decimal. 2 root 2 divided by bracket root 3 minus 1 close bracket equals. Type their answer into your calculator. If you get the same decimal, you did it right. Okay. So one of the things I can do with these addition identities, Sabrina, is get more exact values. Okay. Ooh, I can do something else as well. Example 3 says, simplify the following. Holly, can you read 3a to me, please? Nice and loud. That's what Holly said, but that's not what I heard. Here's what I heard. Nicole, are you ready? I heard this. Sine alpha cos beta minus cos alpha sine beta. Because I noticed the first angle was the same in both expressions. Yes? And the second angle was the same in both expressions. Yes? I said, you know what? I think this is really sine alpha cos beta minus cos alpha sine beta. Cos alpha you see how I picked that out a little bit there, Nicole? You see how I spotted that a little bit there, Nicole? Yes? Are you here, Nicole? You sure now? Can you read that to me, Nicole? Out loud, nice and loud? Sine. Can you read that to me nice and loud? Isn't that what you just read to me? Then doesn't that also mean that it's equal to this? Ah! So are you saying that this is also equal to the sine of alpha minus beta 100 degrees minus 10 degrees? Katie, do you see how I put that little chain of reasoning together? I spotted hey, it looks kind of like, sort of like one of the identities from my sheet with numbers in it. So let's see if I can generalize it, figure out where it came from. And then let's go put right on the left-hand side. Except, hey, Steph, what is 100 degrees minus 10 degrees? And this I can get without a calculator. In fact, 90 degrees, behold the human unit circle. One more time. 90 degrees is right here. What was the sine right here? Remember, unit circle sine was the y value. How high is my arm right here if my arm is 1 long? What's the sine of 90? 1. This whole thing here works out to 1. Mr. Dueck, why don't I just type it into my calculator and get the 1? Why don't I just go sine 100 cos 10 minus cos 100 sine 10? Have we done non-calculator sections occasionally this year? This would be, on your final exam, a good non-calculator question on your final. It won't be non-calc on this test because I told you this second test is all calculator. It doesn't have a non-calculator section. But this will be another example of where else I could throw an entry. Okay. Ragji, could you read this to me, please? Alpha. Stop. Here's what I see. I see cos minus sine. Do you see cos minus sine? Yeah? Then let's try and fit it into those identities at the top of the page, but let's call this first thing here alpha, and the second thing here beta, and it's also going to be way easier for you to read. So you ready? Scene 1, act 1, take 1. Cos minus alpha. Isn't that still the same thing as they had in the first one? Oh, you know what? Let's be really clever. Let's go like this, like that, and like that, so we can see it easier. Now here's my question. Roxanne, from those 4 identities in the box up there at the top of the page, or on your formula sheet, which one is cos alpha, cos beta minus sine alpha, sine beta? What's the left-hand side that matches that? Which one is cos minus sine? I can't hear a word you're saying. I want more specific because I haven't got these memorized. Read me the left-hand side, please. Is she right? Is it cos alpha plus beta? Okay, so if I hear you right, you're saying this is yeah? You are correct, my dear. But now, let's actually plug in what alpha and beta are. Okay? It's going to look like this. Cosine. Ragji, what did I say alpha was? What did we write our alpha under? The whole thing now. Read it out to me. 1 over 4 pi minus theta, yeah? So try it again in one complete sentence without hesitation. What do we write our alpha under? Read me the whole, what is alpha? Read me the whole thing in that bracket there. I totally agree. Okay, that's that part. And then Ragji, what do I write right here? Read that to me. No, even but read that, the middle thing there. Blah, plus. Now, yeah, finish the punchline. Hey, do you notice anything there? Does that bracket simplify at all? There's something screaming out at me that I see. Ah, are you really? Those go away because you have a plus theta minus theta? In fact, you have 1/4 pi plus 1/4 pi? Oh. What's a quarter plus a quarter? So what's a 1/4 pi plus a 1/4 pi? Half pi, and all of you right now are thinking of food, I realize, but okay, 1/4 the number pi plus 1/4 the number pi. Are you saying that this is actually the same as the cosine of, and instead of writing a half pi, can't I write it in the more familiar way that we're used to? Yeah. Oh, Mr. Dueck. Yes, Holly. I know the answer because I know an exact value for the cosine of pi by 2. And where is pi by 2? Pi by 2 is, well, there's pi. Oh, pi by 2 is right there. Cosine. Okay, behold the human unit circle. Right here. What's the cosine right here? Cosine was it was x over r, right? So it's your x coordinate. So if I'm straight up, what's my x coordinate? What's the cosine right here? Mr. Dueck. Mr. Dueck. Mr. Dueck. Are you telling me that that whole monstrosity that we even had trouble reading, you mean everything has a 0? Yeah. Well, that's both nerdily cool and nerdily disappointing, Mr. Dueck. So on your test as a multiple choice question, I'll give you some kind of addition identity in disguise. I'll give you the right-hand side, and I'll make you go find the left-hand side and simplify. Oh, you're also eager? Yes, let's turn the page. Example 4. Okay. I like this question. I like this question. I like this question. This is a nice question. Read example 4 to yourself without freaking out. You okay, Nicole? Leave Shannon alone. She's trying to learn. She doesn't need your distractions. Given cos of alpha is 3 over 5, and cosine of beta is 5 over 13, and then I think it's telling me what quadrant those angles are in. That's probably going to help me figure out whether certain things are positive or negative using the CAST rule. Let's say alpha is between 0 and pi by 2, so it's in this quadrant, and beta is between 3 pi by 2 and 2 pi. I'll sketch that in a second. What does it want me to find, Amanda? The exact value of what? Ah, thank you for the whole punchline. What does it want me to find? The exact value of what? Hey, what is cos alpha plus beta from my formula sheet? Are you telling me you memorized it? You freak. I mean, good for you. She's right. You know what? I think this is going to be kind of plug and chug. Let's see. According to this question, what's the cosine of alpha? 3 over 5? Okay. Oh, this is easy, Mr. Dueck. And according to this question, what's the cosine of beta? 5 over 13. Oh, Mr. Dueck, this is walk in the park. And then a minus sign. What's the sign of... Oh. 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 Oh! Okay, first of all, where is alpha? It says alpha is between 0 and pi by 2. Alpha is sitting right there. Somewhere. I don't know. Is it somewhere? C-A-S-T. And where is beta? C-A-S-T. Well, it's telling me that beta is between 3 pi by 2 and 2 pi. It's telling me that beta is sitting right there. You know what that means? That's positive and that's negative. CAST rule, right? Oh, I can do more than that though too. And the reason I like this question is we're about to combine a bunch of stuff from before Christmas right until now. Because Ashley, can you read this little line here? Given what? Nice and loud. Alpha equals 3. Now, I did not hear that. Here's what I heard. I'm going to make a little column over here. We're going to call it alpha. Read it again to me, Ashley. Stop. Did you say cosine? Cosine is x over r. Is it not? According to this question, Ashley, what is the x value for alpha? If cosine is x over r and cosine is 3 over 5, what's the x value? 3. What's r? 5. Hey, if I know x and I know r, can I find y? Uh-huh. How? What was the equation that related x and y and r together? x squared plus. In fact, y is going to be the square root of r squared minus x squared, yes? Holy smokes, this is taking us back to like lesson 2 or 3 from last half of trig. What is 5 squared minus 3 squared? Square root? You tell me y equals 4? So here's my question. What's the sign of alpha based on those numbers? What over what? Three over 4? I think that would be x over y, which I'm pretty sure is cotangent. Ah, y over r? Oh, now I can see where we're going. I bet you we're going to do the same thing over here for beta. Which trig function did they give me for beta, Leah? Oh, and which trig function was it? Cosine? You know what? I think they told me that x is 5, r is 13, and I'll bet you I can find y. I'll bet you y is going to be 13 squared minus 5 squared. And I think this will work out evenly. If I'm doing the math right in my head. What's y? $12. Oh, so then I want to put the sine of beta right here. Okay. What's the sine of beta? 12 over 13. There's the exact value, although I can tidy this up a bit. First of all, how do I multiply fractions together, Ryan? Top times top, bottom times. Oh, so if I hear you correctly, Ryan, you're saying it's going to be 15 over 13 times 5, 65 minus 48 over. Wait a minute, Mr. Dueck. Wait a minute, Mr. Dueck. We need to make a tiny adjustment. Where is beta sitting? In this quadrant? Is y positive or negative if I'm down there? Should be a negative right there. Need to put a negative right here. Fact. Ragjeet, this ends up being a minus minus, which is a what? Oh, plus, and then it's going to be 4 times 12 is 48. 5 times 13 is 65. Oh, do I have a common denominator already? Oh, cool. 15 and 48, I can just add them together over 65. 15 and 48 is 63? Hey, I can, you know what? I don't even know what theta is. I don't know what alpha is. I don't know what beta is, but I can tell you the exact value of the cosine of alpha plus beta is 63 over 65. Exactly. Example 5. Last one. Scribble it out. We're going to replace it with a different question. And the different question looks like this. Evaluate. Cosine of 3 pi by 2 minus theta. Now, Katie, the fact that I scribbled out a question and replaced it with a different question in the lesson should hint to you about something. I like this question. I like this question. Itzel, can you read it to me? Evaluate cosine of what? that's what she said, but that's not what I heard. You know what I heard? Alpha minus beta. See it? Okay. Cosine of alpha minus beta is the same as what? Can you substitute it? Yeah. Cos alpha cos beta plus sine alpha sine beta. This will be a multiple choice question. And the answers are going to scare you because I'm going to give you this and the answers are going to be as follows. You can tell you this. 0, -1, 1. Sorry, not 0, -1, 1. The answers are going to be sine theta, negative sine theta, cos theta, negative cos theta. I'm even telling you what the answers are. That always scares kids because we start out with something this ugly and they, where'd everything go? Where'd the 3 pi by 2? Let's find out. Do you know what cosine of theta is? No. But do I know what cosine of 3 pi by 2 is? Yeah. 3 pi by 2 is right there. What's the cosine of that angle? Now remember, cosine is your x-coordinate. So what is your x-coordinate if you're right there? Your x-coordinate. Amanda. This is 0 times cos theta. That's what the first term works out to. Oh, and then there's a plus sign. By the way, what is 0 times cos theta? What's 0 times anything? In fact, that whole first term vanishes. What's the sine of 3 pi by 2? Because that's the next term. And then I'll drop the sine theta down. Oh! What's an easier way to write -1 times sine theta? Just negative sine theta? What's the answer? Now, here's the question I'm going to give you on your test. It's either going to be a sine or a cos there. I'm going to have a plus or a minus there. One of these two is going to be a theta or an x. And then the other angle is going to be either here or here or here or here. And if I do that, you'll always end up with one of your terms canceling because one of them will be a 0 and then the other one will be a +1 or a -1. And you get a nice answer. There's something like that in your homework and that's going to be on your test. Speaking of homework, what is the homework? You know what? Number 1 is exactly what I told you about just now. Each of these will end up being either positive sine, positive cos, or negative cos when you're done, when you all simplify, when everything's done. 2A, B, and C. 3 is good. 4 is good. 5 is good. Nine is okay. And then you can work on the great big identities review. We are done identities. 2 more lessons and we are done trig.